By referring to the standard normal tables in your set of mathematical tables, answer the following questions. Z is a standard normal variable. Part 1. Evaluate the probability that Z is greater or equal to 1.45. So here we have 1.45 on our curve, and we can see that the shaded part to the right of that is greater or equal to 1.45. So for Z greater or equal to 1.45, it's the shaded area to the right of 1.45. So this is the same as getting 1 minus the probability that Z is less than 1.45. So we know that the area under the entire curve adds up to 1. If we get the area of everything to the left of 1.45, so all of this, and we subtract it from 1, we are left with the area that we're looking for. And the probability that Z is less than 1.45 is 0.9265. So we go to 1.4 on our tables and go across, and go to 0.05 and go down, and we get 0.9265. And 1 minus 0.9265 is 0.0735. Part 2. Evaluate the probability that Z is less than or equal to minus 0.84. Well, we can see that this is approximately minus 0.84 on our curve, and the area to the left of that is less than or equal to minus 0.84. Now we can't get a minus from our tables. There are no minus values. However, the probability that Z is greater or equal to positive 0.84 would be the exact same. So if we have a look, if this is 0 and this is 1, then this line here would be approximately positive 0.84. And if we got the area to the right of that, it is the exact same area as what we're looking for. So now we want the probability that Z is greater or equal to 0.84. But our probability tables always work with everything to the left, or so basically everything that's less than our value. So what we can do is go to positive 0.84, which would be about here. We get the area to the left of that, which would be all of this area, and we subtract it from 1, and it will leave us with the area that we're looking for, which matches up with this area. So the probability that Z is greater or equal to 0.84 is the same thing as 1 minus the probability that Z is less than or equal to 0.84. And the probability that Z is less than or equal to 0.84 is 0.7995. So go to 0.8 and go across, go to 0.04 and we go down, and we have 0.7995. And 1 minus 0.7995 is 0.2005. Part 3. Evaluate the probability that Z is in between minus 1.3 and 1.9. So we're going to start off with the probability that Z is less than or equal to 1.9. So here's 1.9 on our curve, and it's the area to the left of that, so we can straight away just go to 1.9 and read from our table 0.9713. Next we're going to work out the probability that Z is less than or equal to minus 1.3. So again, we have a negative number and we don't have any negative numbers in our table, so we're going to have to rewrite this as the probability that Z is greater or equal to positive 1.3. So if we go to minus 1.3 and we're interested in the area to the left of that, what's less than it, that's the same as going to positive 1.3 and getting the area to the right of it, so the area that's greater than it. So we're interested now in the probability that Z is greater or equal to 1.3. Now we can't work out the probability that Z is greater or equal to 1.3 because we cannot go to the right on our table. We always have to be going to the left. We always have to work with less than. So what we can do instead is say 1 minus the probability that Z is less than or equal to 1.3. So we can get the area of the entire curve, which is 1, and then we can get the area of everything to the left of 1.3, which will be all of this, and subtracting it will leave us with the area that we're looking for, which matches up with this area. So we have 1 minus the probability that Z is less than or equal to 1.3. So the probability that Z is less than or equal to 1.3, we go to 1.3 and go across, We get 0.9032. So it's 1 minus 0.9032, which is 0.0968. So we were asked for the probability that Z is in between minus 1.3 and 1.9. So we worked out that the probability of Z less than or equal to 1.9 is 0.9713. And we worked out the probability that Z is less than or equal to minus 1.3 to be 0.0968. So we're looking for the area in between the two. So that's the same thing as getting the probability that Z is less than or equal to 1.9. So if we got this entire area less than or equal to 1.9, and then if we got the probability that Z is less than or equal to minus 1.3, which will be this, and if we subtracted this from all of this, we would be left with this, which is what we want. So 0.9713 minus 0.0968 is 0.8745. Part 4. Find the value of k, which is an element of the real number set, for which the probability that Z is greater than minus k, but less than positive k. And the probability that this is equal to 0.95. So the area between minus k and k is 1 minus the area of the two tails. So if we were to let this be minus k and this be k, if we took the area of this tail and the area of this tail away from 1, because the area under the entire curve is 1, we are left with the area in the middle. So the shaded area is 1 minus the two end tails. Using the properties, we can come up with an expression for this area. So the probability that Z is greater or equal to minus k but less than or equal to k is the same thing as the probability that Z is less than or equal to k minus the probability that Z is less than or equal to minus k. So the probability that Z is less than or equal to k is all of this area. Subtracting the probability that Z is less than or equal to minus k, which is this area, leaves us with what's in between. And the probability that Z is less than or equal to k is the same thing as the probability that Z is greater than positive k. So the probability that Z is less than or equal to k is this area here, and the probability that Z is greater than k is this area here, which is the exact same area. So then the probability that Z is greater or equal to k is the same thing as 1 minus the probability that Z is less than or equal to k. So the probability that Z is greater or equal to k is this small little area up here, this small little end tail. And that's the same thing as getting the entire area, which is 1, and subtracting the probability that Z is less or equal to k. So subtracting all of this from 1 will leave us with this. So this is equal to this, which is equal to this. So then minus times 1 is minus 1, and a minus times a minus is plus. So we get plus the probability that Z is less than or equal to k. And notice that we have the same thing on either side. So we have the probability that Z is less than or equal to k, and then we have the probability that Z is less than or equal to k. So we have 2 times the probability that Z is less than or equal to k, and we still have the minus 1. So if the probability that Z is greater or equal to minus k but less than or equal to k is equal to 0.95, then that's the exact same thing as saying 2 times the probability that Z is less than or equal to k minus 1 is equal to 0.95. So we've basically just substituted this for this. And now we just have to solve. So first of all, we're going to get rid of the minus 1. We're going to add 1 to both sides. So we get 1.95 on the right. Then we have to get rid of the 2. So we're going to divide by 2 on both sides. So 1.95 divided by 2 is 0.975. So we have the probability that Z is less than or equal to k is equal to 0.975. And by searching for the value of 0.975 in the standard normal tables, we see that k is equal to 1.96. So we search for this in the tables, 0.975, and we see it here, 0.9750, and that matches up with the 1.9 the 0.06, which gives us 1.96. So k is equal to 1.96. So it works out to be 1.96 and minus 1.96. So these were our 2k values, and this was the area in between them. So just to explain a little bit further where we got our different values from. So we started with the probability that z was greater or equal to minus k but less than or equal to k. So basically that z is in between minus k and k. So that would be this area here in yellow. And we said that that was the same thing as getting the probability that z is less than or equal to k, which is from here all the way over, and subtracting the probability that z is less than or equal to minus k, which would be subtracting this. And if you have all of this area and you subtract this area, you are left with this area. So these equate. Next, we said that the probability that z is less than or equal to minus k is the same thing as the probability that z is greater or equal to positive k. So the probability that z is less than or equal to minus k would be this. So this is minus k and this is less than it. And the probability that z is greater or equal to k is going to be this. So if this is k, this is greater than it. And they are clearly the exact same area. So these equate. And then we said that the probability that z was greater or equal to k was the same thing as 1 minus the probability that z is less than or equal to k. So the probability that z is greater or equal to k is this blue area here. So this is k and this is greater than it. And the probability that z is less than or equal to k is this green area. So if this is k, then this is less than it. And if the entire area is 1, then subtracting the green area leaves us with this, which is what the blue area is. So this equates with this.